Graphing parametric equations. Let's explain how to graph parametric equations with this example. This example says, sketch the curve described by x equals t plus 1, y equals t squared, where t is greater than or equal to -1 and less than or equal to 3. We are going to learn two methods to sketch a parametric curve. The first method is called the method with a table of values. In this first method, we are going to use a table of values. So what we do first is to write columns. On the first column, we are going to write the values for t. On the second column, we'll write the values for x. X, as we can see here, is t plus 1. X equals t plus 1. The next column will be the values for y, which is y equals t squared. So this is the first column, the second column, the third column, and then on the last column, we are going to write the order pairs x, y. And these are the points that we are going to plot. And we start. Let's start with t equals -1. For t -1, x will be -1 plus 1, x will be 0. And y will be -1 squared, that will be +1. And then the order pair will be 0, 1. Next value for t, t0. X will be 0 plus 1, 1. And y will be 0 squared, 0. And the order pair will be 0 or 1, 0. 1, 0. Next value for t, 1. And then x will be 1 plus 1, 2. And y will be 1 squared, 1. And the order pair will be 2, 1. Next value, 2 for t equals 2. X will be 2 plus 1, 3. Y will be 2 squared, 4. And the order pair will be 3, 4. Next value for t, 3. That will be the final value, 3. And then x will be 3 plus 1, 4. Y will be 3 squared, 9. And the order pair will be 4, 9. Okay, now that we have our points, and this was the first step, now we move on to step number 2. In step number 2, we are going to plot these order pairs. So for that, what we do is we sketch the axis. Let's say this is the x-axis, this is the x-axis, and this is the y-axis. And then this is 1, this is 2, this is 3, this is 4. 1, 2, 3, 4, 5, 6, 7, 8, and 9. We'll go up to 9 as we can see here, 9. So this is 1, 2, 3, 4, and so forth. And we start plotting these points. So we are going to choose red color to plot that. And we start. When t equals -1, the order pair is 0, 1. 0, 1 will be here. So that corresponds to t equals -1. When t equals 0, the point is 1, 0. 1, 0 is right in here, and that corresponds to t equals 0. Next, we have 2, 1. 2, 1 will be about here, and that is for t1. And then when t2, the order pair is 3, 4. 3, 4 will be about here for t equals 2. Finally, for t equals 3, the order pair will be 4, 9. 4, 9 will be about here. Now that we have the points, the next step will be to join these points with a smooth curve. So it will be something like this, something like that. Now, the final step, when you sketch a parametric curve, the last step is to indicate the orientation. Let me write that in here in black. The last step, number 3, is to indicate the orientation. Now, what is the orientation? The orientation is the direction in which the curve is generated as t increases. This is the orientation. Orientation. We will define in a few seconds. Now, in order to indicate the orientation, what we do is we choose two values for t. Okay, let's choose this value of t -1 and this value here, t equals 0. Now t increases from -1 to 0, so from left to right. So that means that that will be the orientation of the curve. So let's choose red, and then what we do is we indicate the orientation with this arrow, like that, like that. All right, so we continue. That is the orientation. All right, and that's it. That will be the final graph of this parametric curve. And we can see here the difference between curves represented with a function y equals f of x and curves represented in parametric form. Curves represented in parametric form always have an orientation. Now, what is the orientation? Let's define that again. This is the definition. The orientation, sometimes it is called the positive orientation, and it is the direction in which the parametric curve is generated as the parameter increases. Very good. Now let's solve the same problem, but by using method 2. Method 2 is called by eliminating the parameter. All right, so for that, let's write the example again. X equals t plus 1, y equals t squared, where t, the parameter, is between -1 and 3. In this method, the first step will be to write numbers for each equation. We have two equations. Let's call the first one equation 1, and let's call the second equation equation number 2. And we start. The first step in this method will be now to solve for t from any one of these equations. So let's choose equation number 1. So solve for t from equation 1. So from here, from this equation, we solve for t. Then we write t will be equals to x minus 1. The next step, step number 2, will be to substitute this value of t. So substitute t equals x minus 1 in the second equation, in equation number 2. So now we write y equals to t squared, but t is x minus 1, so we write x minus 1 squared. And we obtain this equation, y equals x minus 1 squared. As you can see, the parameter has been eliminated. That's why they call it, this method, by eliminating the parameter. But what is the objective? What do we want when we eliminate the parameter? The objective is to obtain an equation that involves y and x only. And from this equation, then we can determine what kind of curve we are talking about. And you can see that y equals x minus 1 squared represents a parabola, right? That represents a parabola. But this parabola is a parabola that is shifted to the right 1 unit. So now the next step will be to sketch the whole parabola, but the solution won't be the whole parabola. The solution will be just a portion of the parabola. Why? Because t, the parameter, is between -1 and 3. Let me sketch that parabola first. But since it is not the graph, I am going to sketch, meaning it's not the final graph. What I'm going to do is I will sketch that parabola in dashed lines first. All right, so let's sketch the axis. This is the y-axis. This is the x-axis. And now let's change colors. Let's change to red. And then look, this is the graph of a parabola when the vertex is at the origin. This parabola is y equals x squared. But we want to graph y equals x minus 1 squared. So that means that the graph of this equation, y equals x minus 1 squared, is this parabola, but shifted 1 unit to the right, right? So this will be 1 now. So the vertex of this parabola will be here. This is the parabola that we are talking about. Now again, that's not the final graph, but the final graph will be a portion of this parabola. Now, how do we determine the portion? From here. Now, this is how you determine the portion. Look, what we do is, since we know that t equals to x minus 1, what we do is we substitute t onto this interval. All right, so let's do that in here. So we say t, which is x minus 1, is greater than or equal to -1 and less than or equal to 3. Now we add 1 to the whole inequality. And then we'll have here -1 plus 1, 0. Less than or equal to x minus 1 plus 1, x. Less than or equal to 3 plus 1, 4. It turns out that the portion of the parabola is for x between 0 and 4. So we go here, let's change to red color again. So we go here, and then the portion of the parabola will be from 0, let's say this is 2, this is 3, this is 4, so it will be up to here. Now we highlight that portion here. Something like that. Okay. Next, what we do next is to indicate the orientation. Here too, we must indicate the orientation. So this is step number 3. Step number 4. The last step will be to indicate the orientation. You always indicate the orientation when you sketch a parametric curve. And we know that this is a parametric curve because it is the result of graphing a set of parametric equations. All right, so to indicate the orientation, in this case, what we do is we choose two values of t. Okay, so choose 2 values of t. 2 values of t can be t equals 0 and t equals 1. And for t equals 0, you evaluate the value of x here. For t0, x will be 0 plus 1, 1. And y will be 0 squared, 0. So the order pair will be 1, 0. That is for t, 0. So that is the point. This is for t equals 0. We do the same now for t equals 1. For t equals 1, x will be 2. And y will be 1 squared, 1. So the order pair will be 2, 1. So we go here. 2, 1 will be about here. 2, 1. Okay. So that will determine the orientation. Since t is increasing to the right, then we write the direction to the right. And we continue here like that. That is the orientation. All right. And you can see that in this case, we obtain a similar result to this, right? But the second method is better because this tells us exactly that that is a portion of a parabola. Whereas with this method here, we didn't know that it was a parabola. It had the shape, but we couldn't say that it was a parabola. Whereas in this method, we know for sure it is a parabola because we got it here the equation.